The first computer that I ever used was an Apple IIe at the start of the 1990s. I have a lot of fond memories playing text adventures and other games, and many of those memories are from before we had a color monitor, meaning that we used a monochrome green monitor in which each pixel on the screen is either on and bright green or off and black, which really appeared to be a very dark green. Lately, inspired by a video and book on the making of Jordan Mechner's Prince of Persia for the Apple II, which was in color, the Apple IIe has been on my mind, and I've been wanting to replicate its classic monochrome look. So I created a program in Python using Pillow that takes any image as input and gets it very close to the level of detail and overall appearance of graphics on the Apple II. Here are a few examples, followed by some details on how it works. The program takes a file as input, or we can just go with a default image that I have set up. So that takes this picture of a dog with a ball and turns it into this picture. And so as you can see, everything is either a very bright green or a very dark green. So let's try another one. Here in my project folder in the images, I have another one that's called Alley Cat. So let's give that a try. And again, taking this picture, all of the things that are dark in the picture get turned into a dark pixel here beyond a certain threshold, and everything that's light gets turned into a bright pixel. So the sort of silhouette of the cat is visible. For one more example, I think another one that's good is probably, let's go with a starling. So here for starling, I'll take a picture of a starling sitting on the corner of a roof and give us that. This works very well for images in which there are dark objects silhouetted against a bright background, or images that have objects that have dark and light areas that are very well defined. Breaking down how this filter works, what we're essentially doing is scaling the image down to fit into what is known as an Apple II double high resolution size, which is specified at 560 by 192 pixels. So this actually produces a very skewed image at first that looks half as tall as it should, because really what is on display in an Apple IIe monitor is something that looks more like 560 by 384 pixels, or double the height that is specified here. And as far as I can tell, what's happening there is that each pixel that we see on the screen is really twice the height that it is wide. And to emulate this level of detail, what is happening is it's being scaled down to that, then that's the maximum amount of information that we would get on an Apple IIe screen. And so we take that, turn each of its pixels either a bright green or dark green to simulate the monochrome effect. And so after the image is turned into monochrome, what's happening is that the image gets scaled up first as a part of it to fix the skew that we are seeing up here in 192, basically turning that into 384 pixels tall to make it look like the picture really should, at the correct aspect ratio. And then the image is scaled up by 1.5 times to prepare for simulating scan lines on every third row of pixels. So this is something that would often show up when you're viewing it in person, not necessarily like a screenshot or what it was intended to look like, but on Apple IIe monitors, there are sort of barely discernible gaps between pixels, and especially happening on the rows of pixels. So to simulate this appearance that I remember, I'm adding these lines artificially, but essentially turning every third row of pixels into a dark green to simulate those scan lines. And then the image is scaled up again to around 20 times the size of the Apple IIe resolution for viewing full screen on high resolution displays. And that's it. If you'd like to see more detail about how some parts of this program work, like the scaling or the monochrome effect, take a look at the URL to the GitHub repository in the video description. Thank you.